All right, so here are some explanations to these problems that you had the answers wrong to on the last time you took the test. The first one here was said t equals 0. The graph is at 5 centimeters. The amplitude is 5, and the period is 4. So that means that if you're looking at this graphically, it is up here at 5, and since the amplitude is 5, it's going down like that and continuing on forever in both directions like so. And going from 5 to 0, no, not from 5 to 0, because the amplitude is 5. That means it's 5 up and down, so it's actually going down here and then back up. There's how it looks now. And this distance from here to there is the period, which is 4. So because it starts at its maximum, it is easiest to use the cosine function, because cosine is this one that goes like this and starts at its maximum and ends at its maximum in one period. So then, since the amplitude is 5, that has to go in the front. And it is not shifted up or down or right or left any, so now all we have to do is figure out the period. And the period is always equal to 2 pi times some value of b, or whatever variable you want to use. And so since we know that the period is 4, and we have 2 pi times b, so now we have to solve for b, and we would divide by 2 pi on both sides. So b equals 2 over pi. Now, when you put that into the equation, though, it has to be the reciprocal because it's affecting the x value, and anything that affects the x value has to be the reciprocal thing. Just like in any common graph that you have, if it's shifted left, like left 2 places in the parentheses, it would be something like x plus 2 because it's the inverse thing that happens. So here you would have pi over 2x. And that is how you would write that function. All right, now you are supposed to solve this equation for theta. And this was in the interval from 0 to 2 pi. And I can't remember if it was like this or if it was like that. This one means that it includes 0 but not 2 pi, and this one means that it doesn't include 0 but it includes 2 pi. In this case, I don't think it's going to matter because you're not going to get that answer anyway. So first thing you would do is subtract 1. And you'd have a negative cosine of theta equals that 2 minus the square root of 3 all over 2. Common denominator is 2 over 2. And so now you have 2, and then 2 minus 2 is 0. So now we have a negative square root of 3 over 2. Next thing you would do is get rid of the negative sign by multiplying both sides by a negative 1. And you have cosine is the square root of 3 over 2. Finally, you would take the inverse cosine of the square root of 3 over 2. Now, if you do this on your calculator, if you are in radian mode, you would get a radian measure. If you're in degree mode, you would get a degree measure on your calculator. If you get some decimal thing, then your calculator must be set to radian mode. If you want to figure out what the degree is when you do this, then you would want to multiply by 180 and divide by pi, and that would get you it into degree mode, or that would get you the degree answer. But this is one of those, because it is the square root of 3 over 2, and we're talking cosine, so that's got to be something in this quadrant that you're going to be looking for. And for cosine at the square root of 3 over 2, that is a 30-degree angle. And the reason I know that is because of a lot of things. It's part of a 30, 60, 90 triangle. Where that's 1, that's 2, that's the square root of 3. And so cosine is the adjacent over the hypotenuse. And so that's this angle right here. 30 degrees is also pi over 6 in terms of radians. And like I said, the decimal form is whatever 3.1415 divided by 6 is. Now, cosine, if you recall from the unit circle, if that's 1, cosine is the x value. It's cosine sine. And cosine is the x value. And where else on this circle is the x value the same sign? Is it here, there, or there? Well, because cosine is the x, x has to be positive, and x is positive in this quadrant and that quadrant. So we're talking that angle, which is pi over 6. We're also talking this angle that comes here and ends there, which is 11 pi over 6. Because all the way around the circle is 2 pi or 12 pi over 6, and you're taking away a pi over 6 because that's what 30 degrees is. Or if you look at it in degrees, if that's 30 degrees, this angle this way from here to there is a negative 30, which makes that angle 360 minus 30, or 330 degrees. So those are the two angles that fit this equation that are between 0 and 2 pi. All right, so now this one says cosine, inverse cosine of 1/2. Again, it's cosine. We're trying to figure out where is it 1/2, and cosine has to be a value that is in either this quadrant or this quadrant. And so cosine is a half. It has to be, it's a positive, so now that eliminates this side, and instead it has to be something over here. Now again, if you use your calculator and just put that in, if you're in degree mode, it's going to give you a 60-degree angle. If you're in radian mode, it's going to be whatever pi over 3 is. It's like 1 point something. And so then that's your answer. This is a button on your calculator. It's the shift of cosine. The next question was arc sine of x, and I'm not remembering what it said there. I didn't write the whole question down, but it was false. I think it's talking about a function. And I don't believe that is a function because it's not a capital A. Because if it is a capital A, then if it's written this way, or arc sine, I should say, then I think that's what it's talking about, a function. I'd have to go back and double check that one, and I will a little later, but I think that's the way it teaches it in this book. Or not in this book, in this online course. The capital one means it's a function. The non-capital one means it's not a function, one way or the other. Like I said, I'm going to have to look that one up because I've not really ever dealt with that before in teaching pre-calculus, so it's kind of a new one to me. Sad to say. All right, so moving on. This one here, solving this. Because you have these two things multiplied together to equal 0, you can use your zero product property and just set this equal to 0. And when you solve this, it would be sine of x equals a -1. And so then x equals the inverse sine of a -1. And if you think about that on the circle, or you put it into your calculator, a -1 for sine. Sine is the y value. That has to be this one right down here, which is 3 pi over 2. Now this other side, if you set that equal to 0, this is a quadratic equation just like 2x squared minus 3x minus 2. And I think that is factorable because there are factors of 2 and a negative 2 that you can multiply and get to a negative 3. Because if that's 2x and that's x, and you put a minus 2 there and a plus 1 there, I think that works. Let's see, that's a negative 4 and a positive 1, which is a negative 3, and that's a negative 2, and that's 2x squared. So yes. So now we replace that with x with the sine of x, and so then your factors become 2 sine x plus 1 and sine x minus 2. And they have to equal 0. And so now by your zero product property again, 2 sine x plus 1 equals 0, and sine x minus 2 equals 0. Now you have to solve both of these two equations. We will start with the one on the left and take this one here. Subtract 1 and have 2 sine x equals a negative 1. Then we would divide by 2, and you have sine of x equals a negative 1/2. And finally, you would want to get rid of the sine, so then x equals inverse sine of a negative 1/2. Again, you can put that into your calculator. And where is sine a negative 1/2? That has to be, sine is your y value, so it's down here. There are two angles. One of them at this angle here, one of them at that angle there. That would be 7 pi over 6 and 11 pi over 6. Because when sine is a half, it's a 30-degree angle from the x-axis somewhere, either here, there, there, or there, and because it's a negative, it's got to be on the downside. All right. And again, you can put that in your calculator, and you would get one of these answers. You would get this, actually, the answer you would get using your calculator would be a negative pi over 6, which is this angle from here to there. Now, I do believe that the initial question said between 0 and 2 pi. So now you have to use your intelligence to know that a negative pi over 6 is not between 0 and 2 pi. And so then you have to figure out angles that are between 0 and 2 pi that still fit this, which since that says a negative pi over 6, you just take 2 pi minus pi over 6 to get that one. And then because it's on this side as well and down, and that would be a negative pi over 6, then you would also take pi minus pi over 6. Or no, that would be plus. Yeah, no. Check that. It would be minus a negative pi over 6. Talking too fast, and I forgot what I was going to say. So minus a negative is plus, so then pi plus pi over 6 is 7 pi over 6. All right? Hopefully I didn't confuse you too much with that part. Okay, then this last one. If we're going to solve this, we would add 2. Sine of x equals 2. Then we want to get rid of the sine, so we inverse sine it of 2. Now, by your rules of inverse sine, the domain for that has to be between a negative 1 and positive 1. 2 is not in that interval, so therefore there are no answers to that one. And so we have 3 answers to our. And there we have it solved. All right, so now here it says pi over 4 is a solution to the 3 square root of 2 secant theta plus 7 equals 1. Well, you can substitute that into it, and you have 3 square root of 2 secant pi over 4 plus 7 equals 1. And now just figure it out. This is no different than 1 over cosine of pi over 4. Now, what is the cosine of pi over 4? That you should know is the square root of 2 over 2. So it's 1 over the square root of 2 over 2 times 3 square root of 2 plus 7 equals 1. And now this, the reciprocal of that would be 2 over the square root of 2. And so now if you're going to multiply those things together, those would go away. And 3 times 2 is 6. And 6 plus 7 is 13, which is not 1. And so therefore, that would be a false statement. All right, now this one again. How many different solutions does this have? There is only one, because it's talking about the function, and for the function, it can only have one answer, because each x has one, only one y, because it has that capital C. All right, so now we have another one of these where you had to figure out if it was a solution or not. So you have 4 cosine squared of 4 times 5 pi over 4 minus 3 equals 0. And so we have 4 cosine squared, and those go away. And now you have 5 pi minus 3. And then when you figure that out, this is cosine of 5 pi minus 3 squared, and 4 times it, and it has to equal 0 still. Well, 5 pi minus 3 is some decimal thing, and if you take the cosine of that and then square it, you're going to get some number here. And if you multiply that by 4, you're not going to get 0, because this is not 0. And so therefore, no, it's not a solution. All right, and then this last one, solving. I think this is the last one. Yes, it is. Here you wanted to get general solutions. So now we're not talking an interval. We got to figure all of them out. So it's cosine of x equals 0, and cosine of x plus 1 equals 0, because of the zero product property again. And so now if you take this, you get x equals inverse cosine of 0. And here, cosine of, oh, we'll just stick with the one side first so we can explain that. Get to that later. So now where is cosine 0? Cosine is right there, 0. Oh, but it is also right there. But by definition of the domain, it's only an angle on this half of the circle, which is pi over 2. Now, had it given you an interval of 0 to 2 pi, you'd be done. Well, you'd have to say this one down here. But now, here it wants a general solution, so you've got to come up with the angle, all of the angles that it possibly could be, which in this case, there's just the 2. There's this one up here, marked in yellow, and then there's this one down here, marked in purple. Those two angles both have cosine being 0, because the cosine of a 90-degree angle is 0 and the cosine of a 270-degree angle is 0. Nowhere else is that possible. And so that angle is 1 and that angle is 1. And also if you come back to this angle, to there, let's go. If you do that, that is another angle that is 0. And if you go around the circle this way, that angle is 0. And so the distance, hmm, the length of the arc, or the distance from there to there, is 180 degrees, or pi. And so you have pi over 2 plus pi n. Then, and another way, well, this also can be written as pi over 2 plus 2 pi n, because that's this angle, and then that angle, and then that angle, and then keep going around. And then if you want to use the other one, it's 3 pi over 2 plus 2 pi n as well. I think here is how the question gave you the answers. This one would be the way I would look at it, but they don't show you that method, I don't think. So going back to this, just one more time, because you know cosine is 0. And you know cosine is 0 here, and it is also there. Those are the only two places. So this angle is pi over 2, and this angle is 3 pi over 2. And then the next angle that would be at pi over 2 is be if you add 2 pi n or subtract 2 pi n. And so that's why it's plus and minus. But if n is an integer, I don't see why you have to put the minus, but that's the way they have it in the lesson, and that's how they have the answers. So that's why they put plus and minus there. All right, hopefully you followed all that. If not, let me know and I'll try to re-explain that part to you. Okay, so now on this one, do the same thing. Cosine of x equals a -1 because you're going to subtract 1. Then you take the inverse cosine of both sides. So you have inverse cosine of a -1. Now this one, if you're looking at it on a circle, or if you put it in your calculator, you would get this angle right here from there to there. That is 180 degrees, or pi. Nowhere else is cosine a -1. And so the next angle, again, plus and minus then, 2 pi n. And then that would conclude your answers. So you have this one, and that one. So there are 3 angles between 0 and 2 pi. There's infinite angles if you don't have that. And that is everything that you had from that test. Like I said, I'll check on that arc sine thing and let you know about that tomorrow. Hopefully this helps you out some and you can retake that test. I will reset it here tonight, and then you can give it another shot tomorrow or the next day or whenever you feel comfortable with doing that. Okay.